This video is going to be on solving absolute value inequalities. When we want to solve absolute value inequalities, it'll be easier to look at two basic problems to kind of get the idea. So the absolute value of x will be less than 4, and the absolute value of x is less or greater than 4. So two types of problems, two problems that we can solve just by thinking about them, and we're going to think about what kind of numbers would work for x, and what kind of numbers, and what we're going to do is we're going to put them on a number line. So think about, for number 1, what kind of values for x would work in order to make the inequality true. So let's start with 4 itself. Does 4 work? When you plug in 4, it becomes the absolute value of 4, which is still 4, and that's not less than 4, so that doesn't work. But numbers that would be less than 4 would be things like 3, 4, or 2, excuse me, 1, 0 would work. When you put in -1, you do the absolute value be positive 1, and then that would also be less than 4, so that would work all the way up to probably -4 again, because when you put -4 in, the absolute value of -4 would be 4, and then that wouldn't work. So one thing we want to see is that all the numbers that work seem to be in between -4 and 4, and a way to write that as an inequality would be as follows: -4 is less than x is less than 4. So it's called a and compound inequality. So one thing I do is I call this guy a less than symbol, because anytime it's less than or equal to or less than, the absolute value is less than the constant, it's going to be an answer where you find your values for the set in between the two numbers. And the way you can write that is -4, 4 in interval notation. So either would be good or acceptable. Let's take a look at the number 2. Think about numbers that would be able to be used for x that would make the absolute value of x greater than 4. Let's start with 4 itself. Once again, absolute value of 4 is 4, and that's not greater than 4, so that's not going to work. But numbers like 5 and 6 and 7, those would all work, and so that's good. So it seems like all the numbers over here and beyond would work. Let's go with -4. -4, the absolute value of -4 is 4, so that's not greater than 4, but things like -5 would be good, -6, -7. So those would all be good as well, and that means we can use these numbers that go towards the left. And so the way to write that is to say that x could be less than -4, or it could be x is greater than 4, and so we have an or inequality, which leads me to say that this greater than symbol is no longer a greater than symbol, but it is greater. And kind of reminds me that when I have an absolute value greater than a number, I'm going to use an or inequality to help me solve it. And so set notation could be written this way: -infinity to -4 with parentheses because it's not equal to, joined by the union, and then 4 to positive infinity. And that's the basic setup that we're going to use to solve an absolute value inequality. So let's try one. It's going to be the absolute value of 2x minus 1 plus 3 is less than 8. And so one thing we want to do first is we want to get the absolute value alone on one side. So we're going to subtract 3 first. And so it's the absolute value of 2x minus 1, and that is less than 5. And then we can set up our inequality. Since I've got this less than symbol, that means I'm going to use an and inequality. I know that the absolute value, if I can get the stuff on the inside, the 2x minus 1, if I can get 2x minus 1 to be in between 5 and -5, once I take the absolute value, I know it'll work. So I put 2x minus 1 in the middle, and I want it to be between negative 5 and 5. Now we solve it as normal. I'm going to add 1 to every side. It's going to be negative 4 is less than 2x minus 1, or no, excuse me, just less than, and we'll go with 4, switch that around. It's less than positive 4, then we, or 6, this is a 6. Then we divide by 2, and so that would be negative 2 is less than x, which is less than 3 also. So the numbers that we want to use for this answer are in between negative 2 and 3. And if you want to write it in interval notation, it would be from negative 2 to 3, and it's parentheses because it's not equal to. And there's our solution. Let's try one that gives us a greater than. So we've got negative, for example, 2 here. We've got negative 2, absolute value of 3x plus 4, and that is less than or equal to negative 10. I know I said that this example was going to have a greater than symbol, and it will, because we want to get the absolute value part alone, so we're going to divide by negative 2, and remember that anytime you divide by a negative in an inequality, you need to switch the sign. So it'll be the absolute value of 3x plus 4, and since we divided by negative 2, it's now going to be greater than or equal to positive 5. Since it's a greater than, right, we now have a greater situation, and the way to set those up is not too bad. You'll keep the first one looking exactly the same. It'll be 3x plus 4 is greater than or equal to 5, or then you'll have 3x plus 4. That's not going to change, but it'll be less than its negative counterpart, so that after you take the absolute value, those numbers will be bigger than that. Oh, I put negative 4 instead of negative 5. So there we go. Alright, we're going to subtract 4, solve each one as normal. 3x is greater than or equal to 1, and then we'll divide by 3. So x is greater than or equal to 1/3. Or, and we're going to solve this one, subtract 4. And so 3x is less than or equal to, forgot that, negative 9, and then divide by 3. And so x is less than or equal to negative 3. So x is greater than or equal to 1/3, or x is less than or equal to negative 3. The way to write that would be negative infinity, comma, negative 3. That's x is less than. We're going to use a bracket because it can be equal to, joined by the union, bracket, 1/3 to positive infinity. And that's how you would solve an absolute value inequality. Have a great day.